In this tutorial, I'll show you how to create sprite animations using Sprite-Sheets. We're going to start with some pre-existing code that just displays a player sprite on top of a platform. The only thing this player is capable of doing at this stage is moving right and left by pressing the arrow keys. So now let's go over the code that makes this possible. At the root of my project, I have the base game class, which is stored in game.py. This code just initializes Pygame and creates the screen with a specified width and height. I also have some useful constants like the current directory and some colors that I can use in any of the game's screens. Then I have a method for exiting the game and handling the quit event that occurs in the event loop. Next, we have the launcher class in main.py, and in this class we inherit base game and we launch a screen. The screen is a class that I use to manage the content that we want to display on the window, and we start by creating our sprites, which are stored in sprites.py, and then starting our game loop. This game loop updates the display at 60 frames per second and then draws and updates all our sprites. So before we start writing any code, I want to go over what exactly a sprite is and what a sprite sheet is. So when we're talking about computers, a sprite is a 2D bitmap that is placed into a larger screen. We use them to represent players, enemies, obstacles, items, and almost every visual element that we can interact with on the screen. In general, we want to move them, to collide with them, or to animate them, and this is where sprite sheets come into play. A sprite sheet is basically an image that contains a lot of smaller images, and we can extract these smaller images to create an animation. So how exactly do we extract these smaller images from our sprite sheet? What we can do to get each image is to use an image editor like GIMP to zoom in and manually obtain the 4 parameters we need to create a rectangle. The 4 parameters we're concerned with are the X position, Y position, width, and height. By selecting the rectangular select tool in GIMP and drawing a box around our sprite, we can get all the information we need in this left pane. Now that we have an understanding of how we can get images from our sprite sheet, let's go back to our code editor. In our project, we'll create a new file called Sprite-Sheet.py. In this file, we'll import Pygame, and then we'll create a class for our sprite sheet. We're going to make this a class because as our projects get bigger and we want to incorporate more sprites, you're likely going to have multiple sprite sheets if you want animations for each sprite. So having a class just makes this a bit easier to manage. In this constructor, we'll add a parameter for the file name, and then we'll create a member variable to hold the loaded sprite sheet image. Next, we'll create a method to get a specific image from the sprite sheet. As I said before, to get a sprite manually from the sprite sheet, you need to know the coordinates of the rectangle around it. So what we need is the X, Y, width, and height, and rather than adding all of these parameters to our function, I'll create one parameter labeled frame. In this frame, I'm expecting either a tuple or a list to be passed in, which contains those 4 values. We can create a Pygame rectangle using this frame, and then we pass that into Pygame's surface.subsurface method. This method just extracts an image given the coordinates from a main surface, which in this case is the sprite sheet. Then all we have to do is return the image. Alright, so now that we have a method for extracting sprites from our sprite sheet class, let's go about getting an image from the sprite sheet for our player. In sprites.py, we'll start by importing path from the OS module. And we're just going to use this to specify the directory and file name of our sprite sheet image. So after we've done this, we can also import the sprite sheet class that we just created. And once we have imported that class, we need to create an instance of it. So under our constructor in the player class, we'll create another function called load. And in this method, we'll create an instance of the sprite sheet. I'll just store it in sprite sheet. And for the file name, we'll use path.join, self.screen.game.image directory, and then we'll pass in the file name player sprite sheet. So basically self.screen in our constructor over here, we have a parameter called screen that we're storing. And within that screen, we also have a field for the game, which is just an instance of the base game. And within that base game, we have a constant for the image directory. And the image directory is just where we're storing all our image assets. So if you go on the left pane over here, you can see in this image directory, we have player sprite-sheet.png. And if we zoom into the sprite sheet, you can see over here we have a bunch of frames, and this very first frame is the one I'm going to focus on extracting first. So in this load method, I'll say standing frame is equal to a tuple 747 1945, and then we'll say sprite-sheet.getImage, and I'll pass in that frame as the argument. Store that in self.image. And then in our constructor, we need to basically get rid of the green rectangle. So we get rid of these self.image calls and fields. And then we can also call self.load at the top of the constructor. Now, we don't really need these position variables either because we're only using them in this constructor to create the initial position of our sprite. The width and height aren't needed anymore either because it's dependent on the sprite sheet image. So I'll get rid of that, and then I'll also get rid of the select parameter, change that to X and Y for the initial position. And then over here, we'll change all the usages to X and Y. So going into screen.py now, we also have to change this call to the player constructor, just set it to be the initial position only, get rid of that tuple, and then we can go to main.py and launch our game. So you can see over here now we're getting an image displayed from our sprite sheet. You'll also notice there's this green background around the image. We don't want that to be outputted on our screen, so there are two ways we can get rid of it. The first is to use Photoshop or GIMP to basically remove the background completely. And the second is to use a tool in Pygame. Basically, Pygame has a function called setColorKey, which we can use to get rid of all traces of a certain color. So if we go back into our Sprite-Sheet file, we can go into the constructor and we can create an optional parameter called background. We'll just store the result of that in a field called self.background. And then in our getImage method, we can see if that field is defined or not. If it's defined, then what we can do is that we can say image.setColorKey, and then we can pass in that background as our argument. And what this will do is basically just remove all traces of whatever color we pass in. So if we go back into sprites.py, we can go back to our Sprite-Sheet instance, and then we can say we want the background to be the color green. And for me, I have the color green stored in my base game class, so you can see over here I have this constant self.green, and if I run this now, you can see the background is no longer visible. But you might also be thinking, this image is kind of small, what if I wanted to increase it to make it look bigger? How could I go about doing that? What you can do is that you can go into getImage and we can create a parameter called scale. And if that scale value is defined, we can call pygame.transform.scale, using the image as a surface to scale up. And then for our size, we need to specify that we want to increase or decrease the width and height. So I'll store the width and height in two variables. And then over here, I'll call width times the scale factor and height times the scale factor. All right, and then if we want to test the scale method, I can go into this getImage method call in sprites.py, and then I can say scale is equal to 2, and that should increase the sprite. Then you can see over here that actually happens. Okay, so currently now we're able to get an image from our sprite sheet, and we're able to display that image on top of our player sprite. We've also added code now to allow us to scale up and scale down that image by whatever factor we want. Now I want you to consider one more possibility. If we go to our Sprite-Sheet file here, you can see that all our sprite images are facing in one direction. They're all facing towards the right. And I want you to consider now, what if we wanted to move the player to the left? We need some sort of way to flip the sprite sheet so that it's facing in the opposite direction. And the easy way to do this is to go into our getImage method, and we add an optional parameter called flip. And by default, we'll set that to false. And now we'll say that if flip is true, we can set our image to be the result of pygames.transform.flip method. And we want to flip along the x-axis, so we'll say true over there, and then false for flipping across the y-axis. And back in sprites.py now, we can say flip is equal to true, so that just for our demo here, we can see how the player looks now. And we can see over here that the player sprite is now facing in the opposite direction. We're able to extract images from our sprite sheet now, but the main goal of this video was to take those images to create an animation. So let's talk a little bit about what an animation actually is and how we can implement this in Python. An animation can be described as a collection of frames containing continuous drawings, where each frame changes quickly to give the illusion of movement. So if we wanted to create an animation object, what exactly would we need? Well, to start, we would need a collection of frames that we're going to switch between. Then we need to know the duration of each frame, so how long we want each frame to be on the screen for. And lastly, we'll need a way to set the frame after the frame's duration has elapsed, so to move to the next frame in our animation. To implement this animation class now, we'll go into Sprite-Sheet.py, and then we'll create a class underneath our Sprite-Sheet class for the animation. In the constructor for this class, we expect the two arguments we just discussed, the frames and the frame duration. We'll store these variables in fields so they're available for the rest of our class, and then we'll create another field for the total animation duration. The total animation duration is just going to be the frame duration applied to each frame in our animation. So we're going to take the length of our frames array and multiply that by our frame duration. The next step to implement in our animation class is frame switching. We need a way to change the active frame in our animation, and to do this we can create another method called getFrame. To switch between our frames, we need to consider time. Specifically, after the frame's duration has elapsed, we need to change the frame. So we need a measure of how much time has elapsed since the sprite animation was started. We can store this in a parameter called stateTime, and we'll use this in our getFrame method to switch between our frames. First, we can start by checking how many frames we actually have. If we just have one, we don't have to do any switching, so we'll just return that frame. And after that, we have to calculate our frame index. So each of our frames has a frame duration associated with it, and once the duration has elapsed, we want to switch to the next frame. So state time is a measure of how much time has actually elapsed within our animation, and by dividing this with our frame duration, we can determine which frame that we want to show. So let's say that our state time was twice that of our frame duration. That means we've gone over 2 frames and we want to switch to the third frame. Then we have an index of 2, which is the third entry in our frames array. The issue with just doing this simple division is that we'll get a float number, so we'll just wrap that with an int, and wrapping it with an int will round it down, which basically confirms that our frame will only switch once this total frame duration has elapsed. Now we'll just play a non-looping animation, and basically we just want to make sure that once we reach the last index in our frames array, we want to stop the animation. So we can take the minimum of the length of our frames array, we'll subtract that by 1 because we want an index value, and then we'll compare that to our frame number index that we just calculated. And then we can just return whichever frame corresponds to that frame index. Now underneath this method, we can create one more method just to check if our animations are finished. This is going to be useful for something like an entrance animation that I'm going to show you in a bit. So similar to getFrame, we're just going to have a stateTime parameter, and we want to check our frame index. So we'll calculate it in the same way that we did in getFrame. And then we want to return a Boolean value that tells us if it's finished. So what we're going to do is that we're going to compare the length of our frames array -1, which is the last index, to our frame number. And if our frame number is bigger than this value, that means that we've gone over how many frames we have in our animation, so it's done. That completes our animation class, so now we can go back to our Sprite-Sheet class, and under this getImage method, we can create another method for creating an animation. The animation frames just consist of images we get from our Sprite-Sheet, so we'll just create this method within our Sprite-Sheet class, and we expect an array of tuples to be passed in representing each frame, and then we need to get some other values for our animation class as well as for our getImage method. So we'll take the parameters that we need for those methods, and then we'll create a brand new frames array. In this frames array, we're just going to call getImage on each of the coordinates that were passed into this method. So we'll use the list comprehension, and then we'll call self.getImage, say frame, and then I'll pass in the scale and then the flip values, and then I'll loop through each frame in self.frames. And I'll return a new animation using this newly created frames and the frame duration. Actually, that should be coordinates, sorry. With the completion of this method now, we have a simple way to create animations using a list of images from our Sprite-Sheet. Let's talk about dynamically changing our player's image now. When it comes to our player's animation, we're going to have different animations for things like running, standing, and an entrance animation. So there are a few things we want to consider. The first is how we're going to store these animations. The way to do this is just to create a Python dictionary where the keys represent the name of the animation and the values represent the actual animation. Then we need a way to change our current or active animation, and lastly we need a way to loop our animations. One more thing we should consider though is that animations aren't going to be just exclusive to the player. Later on, you might want to implement animations for things like enemies, bullets, or maybe some other obstacle. So instead of writing repetitive code, what we can do is that we can use inheritance. We can create another sprite class called animated sprite and we'll inherit this instead. So we'll create a file called animatedSprite.py, and within this file we'll create a class called animatedSprite. And then in this class we'll inherit Pygame Sprite library. In this constructor, we'll have some fields for managing our different animations. So we'll start by defining a field for the elapsed time, which I talked about before. Then we'll have a field for our active animation, and this is going to be an instance of our animation class. Then we'll have another field for the active name so that we can quickly check which animation is currently running. And lastly, we need our dictionary to store all our animations. The first thing we'll do in this class then is create a method to update our elapsed time. So we'll do this in a method called update with a parameter called dt, and we'll update the elapsed time by this value. Next, we'll create a method for storing our animations, and within this method we'll take two arguments, the name of the animation and the animation itself, and then using our dictionary we'll store the animation name as the key and the value as the actual animation. Then if no animation is playing, we want to start this as the active animation. So let's create a method called setActiveAnimation, and this is where we'll do this. In the setActiveAnimation method, we expect one argument for the name, and then we want to check if this name is within our animation storage keys. If it's not within our animation storage dictionary, we can return. And if the animation is already running, then we also want to return. Now what we want to do in this method is to change our fields to tell us that an animation needs to be run. So we can start by saying that our active name is equal to the name that is passed into this method, and then our active animation is the animation that we stored in our dictionary. Then we can say that our elapsed time is equal to 0 to signal that a new animation is starting. Lastly, we'll create a method called isAnimationFinished that takes no parameters. This method will just check if our animation is currently finished, and to do this we can just take the active animation and we can call our isAnimationFinished method on it. The active animation is an instance of our animation class, and as you can see over here from before, we created this method and it takes a state time parameter. In this instance, we're passing in elapsed time as the argument to our state time. And that should complete our animated sprite class. So now we can go into sprites.py, we can import that animated sprite class that we just created, and then in our player we'll inherit this class instead. Now if we scroll down into our load method, you can see we currently have that standing frame appearing on our screen. We'll change that now so that we're showing our entrance animation instead. So I'll erase all this code here. Then I'll define some entrance frames. And then in our animation, we'll call SpriteSheet.getAnimation using these frames with a frame duration of 0.13 seconds and a scale of 1.5. Then I'll store this animation in our dictionary with the name entrance, and the value is the entrance animation that we just created. All that's left to do now is to get our entrance frames, and we can use GIMP to extract the coordinates for each image. Now that we have all our frames for the entrance animation stored in this array, our entrance animation is loaded and ready to go. So the next thing that we want to do now is to actually update the player's image and create a rectangle around that image. So we'll create a method here called animate. And before editing this method, we need to change something in update. So we need to call the superclass's update method. And this takes a dt parameter. So what we'll pass in as an argument is the inverse of the FPS, which means that we want to update our elapsed time by a second every 60 frames. Then we'll call self.animate here. And now in our animate method, we'll say self.image. We'll call our active animations getFrame method, and we'll pass in the elapsed time as the argument. And then we need to create a rectangle around that image. The other thing we need to change is that in our constructor, we need to define our initial image now. So we'll have to say self.image, and we'll just pass in 0 as the argument to our active animations getFrame method. Okay, so if I run the game now, you can see our entrance animation is being displayed on the screen. So that completes our very first animation. Next, we'll add our player's standing animation. Back in sprites.py in our player class, in our load method, we'll just add our standing animation below our entrance frames. And once we've loaded that animation, we can scroll down into our animate method. And basically we want to check if the current active animation is the entrance one. And if it is, then we want to check that once this animation is finished, we can switch the animation. So if our animation is finished, then we set our active animation to be standing. Then if we run the game again, you can see our entrance animation is playing, and right after, for a few frames, our standing animation plays. But you can see our standing animation ends abruptly. We don't want that to happen, we want it to be looping. To get the animation looping, what we can do is specify the play mode of our animation. So within our animation class, I'll create an enum object called play mode, and I'll need to inherit Python's enum library. And within this enum, we'll define two options, normal and looping. So say normal is equal to 1 and looping is equal to 2. And then within our getFrame method now, we need to make some changes. So if our play mode is normal, actually I don't have the mode saved here, so I'll go into the constructor and add mode. And then if self.mode is equal to play mode.normal. Then we'll just play this frame number code here that we have already. But if it's not normal and if it's looping, then what we can do is that we can take our frame number and we can apply the modulo operator to it. So we can say frame number modulo the length of our self.frames array. And basically that'll just give an index that resets to 0 if we go over our frames array length. In our get animation, and I'll add a parameter mode as well. And then when we're returning our animation, I need to pass in mode there as an argument. And in our sprites.py, we'll also import animation now because we're going to need it for the play mode. And when we're calling get animation, we need to add the play mode that we want. So for entrance, we want normal. And for standing, we want looping. Okay, so now if we run our game again, our entrance animation is playing, and then you can see our standing animation plays without any of that stopping that we were seeing before. The last thing I'm going to do for my player sprite is to implement 2 more animations for running and halting. And if we run our game again, see from our standing animation, we switch to running. And then if we zoom in, once we stop running, we can see that the halting animation plays. To wrap this video up, I just want to mention that you can find a lot of guides online that aren't as modulated as this guide has been. But the main reason that we did it this way is just to show you how easy it is to create animations for multiple sprites. So I've created an enemy class over here, and you can see that we're also inheriting an animated sprite in this class. And look how easy it is to create an animation. We just follow the same steps that we did for the player. We load in our standing frames, we have an animate method, and then we have an update method. If we play our game now, you can see our enemy sprite is just animated as well so easily, and so much more simpler than it would be if we didn't create that parent class. Anyways, I hope you enjoyed this video. If you have a question, please leave a comment below, and if you liked it, give it a thumbs up and share it, and please subscribe to my channel.